Hello everyone. In this experiment, we are going to see the design and simulation of flyback converter. So flyback converter is basically a DC to DC buck boost configuration converter that provides an electrical isolation. So here we can use a linear transformer. So it's differentiate between non-isolated converter and isolated converter. So generally these are used for a protection purpose. So in this we are going to see the design. So how we can design means there are two steps. So we are going to take V0 is equal to 40 volt, V1 is equal to 24 volt and P is equal to 40 watts and the resistance value is 40 ohm, then frequency is 100 kilohertz. So step 1 is to determine the duty ratio. So for duty ratio, the formula is N2 by N1 is equal to V0 by Vs into 1 minus T by D. So we can assume the turns ratio be 3. So by using these values, we can calculate the duty ratio. So we can get D is equal to 0.35. So in MATLAB, we can use the linear transformer directly by specifying the input as well as the output voltage. Then the step 2 is to determine the capacitor value. So the capacitor value, the formula is delta V0 by V0 is equal to D by RCF. So by substituting these values, we can get the capacitance value of 17.45. So these are the MATLAB model. So in the MATLAB simulation model, by using this library, so this is a library browser. By using this browser we can select the tools. So for the pulse generator, we can type the pulse generator here. So by typing pulse generator, so this is the pulse generator. So by using this pulse generator, we select and add to block model 1 means the block will be added to the model. So by using this Simulink library browser, we can select all these models from the library browser. So in this we can see continuous, this is the power guy. By clicking this, by show and block name content, you can see this is a power guy. So we are using here is a MOSFET. So for a MOSFET, we want to give a gate pulse. So we are giving a pulse generator. So the flyback converter is a DC to DC converter. So we are giving DC voltage, then one linear transformer, then diode, then one capacitance and one resistance. So for this DC voltage, we are giving this for 24 volt. So we can select the DC voltage block and give 24 volt parameter. Then for pulse generator, we want to give the period as 1 e power 0.5 and the pulse width is 35.71 and the phase delay is 0 seconds. So you want to fix the parameters like this. Then the capacitance, we design the capacitance value 17.45 microfarad. So 17.45 e power minus 6 parameter should be given. So okay, then resistance is a 40 ohm resistance we taken. So we design as a 40 ohm. So we want to give the 40 ohm resistance here. So once we are assign the design, want to save the Simulink model. So once you save, you want to run the simulation. So by click the run button, your simulation is running. So once after compiling the simulation, you can see. So this is your DC to DC buck boost converter. So here we are giving 24 volt, but in the output voltage, by using the voltage measurement, we can see approximately near 38.44, that is approximately 40 volt here. So by seeing the scope, we can see the output. So this is your output, that is your DC output. So see here, it is nearly 40 volt, that is 38.44 volt. So we can select this and we can see this is the ripple. So how your capacitor values having the ripple content. So this is a harmonic ripple we can see here. So this is harmonic ripples. So by changing your capacitance value, we can reduce the ripples. Thus, your flyback DC to DC converter simulation is verified successfully. Thank you.